Hello, today we are going to solve one problem of Hackerrank, that's food and libraries. So you can read the problem statement, but I'm going to explain it in the problem and then we will do a solution. So in the problem, we have been given there is one city and we want to build a library for a city. So they have given us like cities that are city pairs that are connected or that they have said. So one two connected pairs means one is connected to two. That means we can build a road between one and two, two and four, two and four, five and six, five and six. Let's say this is given to us. That what does that mean is 3 and 4 are not city pair. So we can't build a road between 3 and 4. That is given. So they have given a city pair. So I have created connected cities like this. And what we have to do is we have to build a library in such a way that every citizen has access to a library. So there is a cost of building a library and there is also a cost of building a road. So what we have to do is we have to build a library or road in such a way such that the cost is minimum. Like suppose I am building it. I want to minimize my cost. I don't care about people if they travel from 4 to 1 or however they travel. I don't care. I just want to minimize my cost. So like if 4 is travel to 2, 2 to 1, so he has to travel long, but we don't care about them. So we just have to minimize the cost. That's the question. So let's see what we can do in the question. So there is a cost associated with building a library as well building a road. So let's see what we can do is let's say we build one library here and in that case if you see cost of building a library is greater than road. Okay. So in that case let's say we build one library here and we build one library here. Okay. So road, how many I need to build? For two to have access to a library, I need to build one road. For three to have access to a library, I need to build a road. If you see the cost for library 2 and road 1, 2 plus 2 4 and road 1 is 6. Total cost is 6. Can I minimize this cost? Let's see. So what I do is I don't build a library here. 2 will go to 1, 1. 4, I will build a road to 2. So if 4 can reach to 2, from 2 it can reach to 1 and it has access to library. So the cost is 1. So in this case, the total cost is I built one library and 3 rows. So 2 plus 3. In this case, cost is 5. Can I further minimize it? Let's see. For minimizing it, at least one library we need. Can we reduce the library? No. So library we can't reduce. Can we reduce the road? No. If I reduce the road to 4, it will not have access to a library. So is this my minimum? Yes. This is my minimum. If I can build one library and there are 4 elements, like 4 cities that needs access. So I can build one library plus 4 cities are there, but I built 3 rows. So like n cities are there, then n minus 1 roads. That will be my optimal solution. I can't optimize it. From here also, I can build one library and one road. So if you see the total cost of here is 5, and here 2 plus 1 equal to 3. So total cost would be 8. That minimum total cost we need to return. Okay. So this is a case where the cost of library is greater than cost of road. In that case, what we will do, we will build one library, other rows. Can we minimize it? No, that's the optimal approach. There is another case. So in that case, what is happening is cost of library is lesser than the cost of road. Okay. So in that case, what we will do? Let's see. So I can build one library here at one and other roads that I did in previous case. So one library is 2 and road cost is 3. Same as that I will do here. One library and one road. One road by there are 2 elements, so connecting one road is needed. So here what is the total? 3 is a 9, 10, 11, 11 for this component and 3 plus 5, 3 plus 2 equal to 5. So total cost is 16. Can we further reduce it? See if we can reduce it or not. So I build one library for 4 as well. So what has happened is my cost reduced. So earlier there was road, so it was 11. Let's see now. 2, 4 and 3, 3, 6. It is now 10. It is reduced. Yes, it is reduced. Can we further reduce it? Let's say I don't build a road from 2 to 1. I build a library here. And the cost is 2. Is it reduced? 2 to 2, 6 plus 3, 9. Yes, it is further reduced. Can I reduce it further? So if I don't build a road here, I build a library here, is it reduced? Yes, now it is 8. So in case cost of library is less than cost of road, we just need to build a library in every C2. So here n into cost of road. That would be my answer. So here also, like this is also a part of this country. So this is, let's say there is one river or something. So this is also part of the country. So here also I need to build a library and here also I need to build a library. Why are they not connected? Let's say there are some big river is there. Like we can't go by road or something. So we are not going to build a whole. We will just go by. We will build a library here and build a library as well here. So that would be our approach. So if you see the solution, like if you see the problem, can you figure out something we can apply? Yes. If you can, it's good. If you can't, please pause the video and try to think about it. What we can do is we can find a way, like we can apply connected components. How connected components? So if you see there is one connected components, we can build either a library or a road. That we have already decided in which condition we are building a road and which condition we are building a library. For these are only 2 cases. Others are not going to happen. So if you see this problem, there is word. If you see at the first time, definitely you will think about it whether it is minimal or not. But these type of problem they are not traditional approach like do DFS and get your answer. No, there you have to think something. This type of problem mostly companies prefer. If you have solved this problem, should be like similar to that little bit of change in DFS and all, you can work. So this will also little bit change in connected components and we can find out the solution. So what we will do, we will, so connected component definitely we need. Why we need? So here also the way we are building one library. But if we build one library and five there is river, we can't build a road from five to one. In that case, we need a connected component. And these are part of this country, okay? So we need for five also access. So now what I will do is I will find the connected components. So for one, if I run the connected components, it will give me all these as listed. So when I run the DFS will go through each and every one once. So if I will ask my DFS, hey DFS, can you give me the count? What count? How many numbers you have listed till now? So that would do my job. How we want to build, we can decide whether we want to build a library or we want to build a like a road. And also, cost of if cost of library is less than cost of road, we don't need to run connected components. No, we know it is given to us how many cities are there. So we just return cost of library into cities. These number of cities are given to us. So in that case, we don't need to bother about anything. So in case when cost of road is lesser than cost of library, in that case also only we'll run a loop and check the connected components and we will build one library plus n minus 1. N minus 1 means whatever the cities that are connected to that component into cost of row. That we will do. So we will ask, so our DFS uses every element. So we will ask our DFS to return the count, how many how many cities it has listed. And every time we get the count, we will build one library plus n minus 1 row. For the case in which building of in which the cost of building library is greater than the cost of code. Otherwise, we will just return total number of cities into a cost of library. So this is going to be our approach. So let's solve the question. So, so I hope you got the idea. So let's move to the coding part. So first we need to build a graph because we have been given cities like this 1, 2, 3, 1. So we will build our graph. So initializing a graph, I have created a graph and initialized every element to empty array list. And now I will build my graph. So graph I will add. Um, Similarly, I will. So if you see, we can go from any city to any city. So it is a bidirectional graph. So we will add from 0 to 1 also. Like if from 1 we can go to this 2, then from 2 also we can go. So it is a bidirectional. We can go in both the directions. So that's why I'm adding in both. So if from 1 to any cities we can go. So our graphs also now ready. Now what we have to do is we need to run a loop for connected components. So boolean listed and its size I would say n plus 1. N plus 1 why? Because I'm assuming that I'm starting from 1. So now we need to run our checks for connected components. So in connected components, what we did is we checked for if anyone is not listed, then it is our new component. So we will start from 1. We will check if it is not listed. Instead of I, then that is our new component. So in that case, we need to, so if it is not listed, in that case, what we need to do is we need to have store in our answer. So what we thought about that answer will be updated, and what will be updated? Cost of library plus whatever this DFS will return. So in this DFS, what we were doing is we were trying to get all how many elements are there in that component. So we will call it DFS and we will pass the listed graph source. Okay, and what this source is nothing but I. So this is not it is returning void. So let me change it to int. We will change our DFS logic. And finally, we will return our answer. Okay. But this okay. Yes. We need to typecast it to long because our answer it is expecting us to a long time. And okay, this is the underscore lip and VFS into our cost of building a road. The underscore road. Okay. So that is going to work. And here, what we have to do in our DFS is just have like have a count of how many elements are there. Int count is equal to 0 and count plus equal to this, and finally return the count. I will explain this count logic as well. Don't worry. Let's check it should work. Um, here also let me typecast it to wrong so that it doesn't give me any compilation or error. Okay, there is something wrong. Let's check. Okay, answer not equal to this. Answer plus equal to. Now it should work. So okay. If it is not listed, These are numbered from 1, that shows fine. Okay, it is less than equal to n, and now it should work. Okay, okay, yeah, here this was the mistake. We need to count this element as well. So I will explain this code after it is successfully ran. Mhm. Successfully ready. Okay, that is the error. It is 10 finally. We need to reduce it by 1. So this was the error. Now it should not fail. Instead of oh, I missed one condition here at the starting. At the starting, what we discussed is whatever be the solution, if the cost of building a library is less than cost of building a road, then we will not even check. In that case, what we will do is we will return cost of road, sorry, cost of library into total number of elements, that's total number of CPUs that is given as n. So in that case, that would be the answer. Let me run the code again. It's passing. Let me submit it. I have to explain that it gives us logic again. Okay. Okay, so I got it. Why it is failing? It is failing is because of this. So let me typecast it to long. Because the number is getting looking for an integer. So that may be the problem. So now it is solved. So let me explain the code of this part. Okay, so if you have got the solution, you can left, but this part I wanted to explain. So let me go ahead and explain. Okay, this is here. So let's move it to the what is happening is, so if we have something like this and we are coming to 1, we will call for 2. We like one's neighbors, then 2 will call for 4. 4 doesn't have a neighbor. So for 4, if this call happens, what happens is it doesn't have a neighbor, so it doesn't go to this. So 4 has returned 1 to 2. Now 2 will 2's call for 1 has already over, and this part has increased count for 2 is 1. Now what 2 will return to 1 is plus 1, right? It will also count himself and it will return 2 to 1. Now for 1, this count in, has been ramped. So for 1, this count is increased to 2. Now for 3, again the call will happen and 3 will call for its neighbor, no neighbors. So 3 will return 1 to this one, okay? And it will increase 1's count to 2 plus 1 equal to 3. And what 1 will return? 3 plus 1. And it will return to our visited. Our visited will have the count. Like this DFS, our DFS will have the count. So this part will this part will get the count from that our DFS function. So we just have modified a little bit to return the count as well, our DFS. So that's the code. I hope you got some good understanding. If not, tell me. I will try to improve. Thank you, everyone. Bye.